Okay, I know that some of you have some problems with the stoichiometric calculations, in special for the lab report of this week. So I prepared this review in order that you uh, have an extra explanation of this problem, and then you can solve any kind of problem. Let's begin by what is a chemical reaction. In a chemical reaction, we have to the left the reactants and to the right the products. The arrow is yield. The reactants yield the product. Here you have the formulas of the reactants and the formulas of the products. The coefficients in front are very, very important, and you know that you can find them by balancing the chemical equation. I'm going to speak about the coefficients. The coefficients represent the number of moles of each substance in the chemical reaction. For example, 2 moles of hydrochloric acid react with 2 moles of sodium to produce 2 moles of sodium chloride and 1 mole of dihydrogen. So 2, 2, 2, and 1 are the corresponding moles of each substance in the chemical reaction. For example, 2 moles of hydrochloric acid produce 2 moles of sodium chloride. Of course, this is theoretically. In the real situations, sometimes you produce less substance than the one that you can calculate. We are going to speak about this later, but these coefficients are the ratios, and these ratios are very important in the stoichiometric calculation. Let's begin by, for example, if you have 4 moles of hydrochloric acid and more than enough amount of sodium, how many moles of sodium chloride can you get? Well, what is given? 4 moles of hydrochloric acid. What is needed? Moles of sodium chloride. That's the question. You know from the question that 2 moles of hydrochloric acid produce 2 moles of sodium chloride. So you begin by what is given, 4 moles of hydrochloric acid. And from the chemical equation, you get this ratio. 2 moles of sodium chloride are produced from 2 moles of hydrochloric acid. Why I write moles of hydrochloric acid down in such a way that I can cancel moles of hydrochloric acid with moles of hydrochloric acid, and the answer is the one that I'm looking for, moles of sodium chloride. This is what I show you in the first class, in the first lecture, sorry. The dimensional analysis, that is the one that you must follow in the stoichiometric calculation. Look, after you do the calculations, you get 4 moles of sodium chloride. As you can see, here you have in your answer only one significant figure. That is the same number of significant figures in the given number. This is very important to report the same number of significant figures as in the given number. Well, what is the atomic mass and what is the molar mass? If you go to the periodic table, for example, for helium, you can see two numbers. The small number is the atomic number and represents the number of protons and electrons, of course. And here you have the symbol of the element, and the bigger number is the atomic mass. These are the grams per one atom of helium. One atom of helium weighs 4 grams. But when you have a compound like sodium chloride, you have to see that sodium, 1 mole of sodium is 22, 98, 97, 6 grams per mole. So you have here the mass of one atom of sodium, and here you have the mass of one atom of chlorine. These numbers are from the periodic table, remember? And then you multiply by the number of atoms of each. In this case, it's 1 and 1. So then you add 22.9897.6 plus 35.453, and you get the molar mass of the compound. This is very important because when you are in front of a compound and you want to convert moles into grams, you have to use the molar mass. For example, how can you go from moles to grams? You have 3.5 moles of carbon, and you know that 1 mole of carbon is 12 grams of carbon. Then using dimensional analysis, you cancel moles of carbon with mole of carbon, and you get that 3.5 mole of carbon is 42 grams of carbon. And here, let's go to an stoichiometric calculation. A stoichiometric calculation. For example, in these chemical reactions, you need to know the grams of this substance that can produce 2.225 moles of carbon dioxide. This is what is given, and that's what is needed. Then you begin from moles of carbon dioxide, and using the ratio, you can calculate the moles of this substance that can be produced, and using the molar mass, you can calculate the grams of this substance that is the question in this case. Let's begin. What is given? 2.25 moles of carbon dioxide, but you know that 3 moles of carbon dioxide can be produced per 1 mole of C3H8. And you know that 1 mole of C3H8 is 44 grams of this substance. How you know this? By the molar mass of this substance. Then after you cancel moles of carbon dioxide with moles of carbon dioxide, moles of this substance by moles of this substance, you can get the grams of the substance that is the question. And in this case, it's 33.0 grams. Look, 1, 2, 3 significant figures because the given number has 1, 2, 3 significant figures. In this case, you are going from moles to grams. You can stop the video at any time and you can see it uh, so many times as you need in order to understand how to do this type of calculation. In this case, I am going from one of the reactants to from one of the products to one of the reactants. But it also can be from one of the reactants to one of the products, and so on. Let's see when you go from grams to grams. In this case, what is given? The mass of iron 3 dioxide. And what is needed? The grams of iron that are combined with dioxide to produce iron 3 oxide. Well, you begin by what is given. And using the molar, in this case, the atomic mass, you convert grams of iron into moles of iron. And knowing well, here is a mistake, sorry. In this case, what is given is 14 grams of iron. Then divided by the atomic mass, you convert grams of iron into moles of iron. Let me stop once again. What is given in this case? 15 grams of iron. And you need to know the mass of iron 3 that is formed from this mass of iron. So you divide the grams of iron by the atomic mass of iron, and you convert this into moles of iron. And then you use the ratio 4 moles of iron produced 2 moles of the iron 3 oxide. And using the molar mass of iron 3 oxide, you can get the mass of iron 3 oxide that are produced. Let's explain it a little slowly. For example, you cancel grams of iron with grams of iron, moles of iron with mole of iron, moles of iron 3 oxide with moles of iron 3 oxide, and the answer will be in grams of iron 3 oxide. You multiply 15 by 1, by 2, and by this big number, and then you divide by this number, and the result by 4, and you get the mass, the grams of the iron 3 oxide. Well, let's go now to what is the limiting reagent. Well, the limiting reagent is the reactant that is completely used up in a reaction. And that determines when the reaction stops. In this case, for example, you have 1, 2, 3, 4, 5 hot dog. And you have 1, 2, 3, 4 bonds. What is the limiting reactant? Okay, You join this with this, this with this, this with this with this. Oh, and one hot dog is in excess. Then you can produce 4 hot dog in bulk, and 1 hot dog is in excess. Then the limiting reactant in this case is the bulk. And the theoretical yield is the number of hot dog in bond that you can produce. Let's see this in a chemical reaction. For example, you begin from 90 grams of iron 3 chloride and 52 grams of uh, hydrogen sulfide. Then you begin doing the calculation of the grams from the grams of iron 3 chloride, and you get the number of grams of hydrochloric acid that you can produce, as I showed you before. This is a calculation from grams to grams. And the same thing, you use the mass of hydrogen sulfide, and you can calculate the grams of hydrochloric acid that you can produce from this amount. Well, you compare both results and you say, well, this is the smallest. So if it is the smallest, this is the theoretical yield, because you can, this reactant, this one, is the limiting reactant, because it's the one that will finish and then the reaction cannot continue, and you will have an excess of this substance at the end. Well, let's see in this case, you can calculate the excess of 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 the hydrogen sulfide. How? Well, you begin by the substance that is the limiting, and you calculate how many grams will react with this amount of iron 3 chloride. Then you subtract the given amount by the one that will react, and you get the excess of hydrogen sulfide that you will have in this reaction. Is the part of this substance that cannot continue reacting because there will be no more iron 3 chloride. Stop the video at any time and do this calculation. It's very important because this is a problem similar to the one that you have in your lab. Well, what is the percent yield? In a chemical reaction, not always you will get the theoretical yield because of many problems. Maybe you don't have the temperature, the pressure, or any other situation that is necessary in order to have the reaction 100% completed. So the actual yield is the amount that you get in the real situation. The theoretical yield is the one that you calculated in, as we have done before. Then you divide the actual yield by the theoretical yield and you multiply by 100 and you get the percent yield. Well, That's all what you need to know by now. You can stop the video at any time and then you will see if you understand or not. If you don't understand, don't hesitate. Ask me any question and I will answer it as soon as possible. See you soon.